So if there's any of these Feynman diagrams to memorize, this is the one I'm about to show you that you definitely have to put on a cue card and try to remember how to draw it and interpret it, okay? Because this one most commonly appears on exams and you have to fill in the blanks and things like that. So I'd be definitely ready to do this one. We can use the Feynman diagram to explain how a neutron turns into a proton in a nuclear beta decay reaction. All right. So in a nuclear beta decay, as we described many times before, one of the quarks changes flavor. A down quark is changing into an up quark. And in order to maintain conservation laws, the result is we also emit a couple other extra particles, a beta particle, which is an electron, and an antineutrino. So in the previous videos, I showed you why those leptons are being emitted and how things are conserved in terms of charge. But we can also illustrate this whole process, not just in a reaction equation, but in a Feynman diagram. So here's the diagram. I have a baryon, okay, which has three. This is my neutron, it's the baryon. And that baryon is being converted into another baryon called a proton, where this down quark is changing flavor and becoming an up quark. And in order to do that, it has to do so using an exchange particle, which are called bosons. So if you look back at that table I presented in a previous video, the weak interactions, which this is, it's a weak interaction, are mediated by bosons, W minus, W plus, Z0. Which boson depends on the nature of the charge coming off. So in this reaction, a negative charge is being spit out. So then I'm going to be using a negatively charged boson to mediate that transfer of charge. Okay, so always remember when a neutron is becoming a proton, a W minus boson is the exchange particle. You might have to fill that in. And that W minus exchange particle is materializing in time. So it leaves and then it materializes into, so time is going in towards left to right, that W minus boson eventually materializes into two particles, an antineutrino, which is moving towards the left, and an electron, which is moving towards the right. So antineutrino arrows always go to the left, antiparticles go to the left, natural matter goes to the right, okay? So that's how this is being described. So as the down quark is turning into the up quark, it emits a W minus boson, the exchange mediating particle, which then decomposes and materializes into a beta particle and the antineutrino. And the arrows, you need to pay attention to how they're drawn. All right? Great. So put that on a cue card, and you'll see a few sample problems in the past few years on paper 2 or paper 1. And just to give you a little breakdown, this is on page 304 of your text. It shows you a little bit more in detail. When a down quark is becoming an up quark, it's mediated by a W minus boson, which is being emitted at the vertex. Okay, here I have an electron becoming an electron and a neutrino pair interacting with a W minus boson. I have a muon and a muon neutrino pair interacting with a W minus boson, and I have an electron just changing direction by emitting a Z0 boson. All right, but this in particular, if you can practice that 6 or 7 times, you'll see it in the test yourself questions. It's a really great one to have down because it could actually be an easy 3 marks if you know how to draw this stuff and you know how to label the quarks.